Welcome to our series on clean energy and energy efficiency. Throughout the series we will have some short 5-minute to 10-minute lessons on key concepts and best practices for you to do in your school as well as your community. Today's lesson will be on solar orientation. We're going to be using our interactive solar display that we see here. If you look at it, we have a solar photovoltaic PV panel. It's an electric panel. Generates electricity. Current comes down. There's a pump located in the bucket which recirculates the water. So the water flow is directly related to or proportional to the amount of solar electricity being generated from the panel. Today we're going to talk about orientation. So orientation means relative to something else. And the orientation that we are most concerned or care about today is the panel with respect to the sun, which is directly overhead. The time is in the morning right now. It's about 10:30 in the morning here in California. So if you look at the display right now, it's pointed optimally and it's flowing. If I turn the azimuth angle, which is the angle with respect to the ground, if I turn it away from the sun, you'll notice that the flow becomes very little. If I turn it back, if I turn the azimuth angle back towards facing the sun, then again the flow is robust. The other orientation is tilt, which is the tilt angle of the panel. Right now it's about 45 degrees, very similar to the angle where the sun is located in the sky. If I were to tilt the panel away from the sun, again the flow reduces. So very simply, by orienting the panel to face as much perpendicular or directly intersecting as much of the sun's rays, you'll get the maximum flow or the maximum electricity generated. Another thing we use for orientation in solar, as we design solar panels for a larger system, for example your house or a commercial building, we use a compass. This is a simple compass. On this compass, north is that way, south, east is directly in front of me, and then west is behind me. If in the morning, again as we know, the sun rises from the east, therefore right now it's 10:30, it's facing towards east. In the evening the sun will begin to set in the west, at which time, if the panel could tilt in an automatic fashion, it would be pointed that way. However, most panels that we design or build are not tracking the sun. There are some bigger systems that will track the flow of the sun. So what we want to do is in the northern hemisphere, and we'll talk about that more in a different lesson, but we'll face it south. South is this way. We tilt the angle of the sun, of the panel to face south, and the reason why that is that the sun rises from the east, which is directly in front of me, and will flow across the sky to the west, which is behind me. And therefore the sun will go directly across the panel, oriented and tilted to maximize the exposure to the sun. What we want to do is we want to be able to generate as much electricity for that time throughout the day. So today's lesson in summary is about orientation in the azimuth angle as well as the tilt, and if you optimize the orientation, you're able to get the maximum current electricity generated. If you do not optimize, then you are not using the solar electric panel to its most highest potential. Thank you.